What do
Like
you
the
mean by
values
weighing?
are the same on both the sides in products and reactants.
Okay, basically, when I talk about a weighing balance, what do you mean by that? Weighing balance. Have you seen any weighing balance? Yes, Vedant. Have you ever seen the weighing balance?
And I don't know the meaning of the word
You
weighing
don't know. You don't
balance.
know the meaning of the word. Yes, Mavish. Do you know the meaning of the weighing balance?
No, sir.
No. Anyone who knows the meaning of the weighing balance? Okay. I'm asking
Is it,
you.
is it an instrument that we use to measure the weights? Like it's held in between, and there are two plates on either sides.
Yes. Yes. You might have seen the electronic weighing balance these days. That when you put on that plate some material, what is its weight digitally? It is shown on the screen. Have you seen that in some journal store somewhere?
Yes, sir.
Yes. That is the electronic weighing balance. Have you seen Sheikh Smriti Iyer?
Yes, sir.
Right. You have seen the electronic weighing balance. I'm talking about the mechanical weighing balance. Have you seen the mechanical weighing balance? John Daniel will tell you something
Yes,
about
sir.
yeah, Vedant. Have you seen?
Yes, sir. Yes.
There are, I will not show you how to do it. Oh, I'm not able to share my screen right now. Students, I'll be back in just a minute. Don't go away. I'll be joining again. Right? I'm not able to share my screen, so I need to leave for a minute and come back. Right? Yes, I'm back. All of you had turned off your all of you turned off your video. Turn on, please. John Daniel, Mavish, turn on. For a second, I went, you turned off. All of you people smart, very smart. Don't worry. Your face is too smart. Okay. So I'm talking about this type of weighing balance where we have a plate here, another plate here. Here in between, we hold it and we put some weights over here. On the other side, the substance is taken whose weight is to be measured. Have you seen this type of
Yes, sir. Yes.
stainless steel? Yeah, this is known as the weighing balance. Suppose I have here 1 kg of any fruit, then I will put here 1 kg of the weights. It means the weight
Wait,
on.
sir, how can we be sure that it will be 1 kg as well?
Pardon?
Sir, how can we be sure that it will be 1 kg as well? The stones.
Not getting you. Could you please repeat?
Nothing, sir. It's a bit out of topic.
Ask me. I will answer it. But I need a clear question.
No, sir. I mean, like, how can we be sure that the stones that are 1 kg as
No,
well?
I'm not talking about the stone. We have a standard weights. Have you seen the standard weights? 1 kg, 2 kg, 5 kg, 500 grams,
Yes.
some made up of the iron, stainless steel.
Yes, yes.
Have you seen? Who has seen? John Daniel? Joe Daniel, have you seen?
Yes, sir.
Yes. Sheikh?
No, sir.
No, we have not seen. Oh. Okay. So we have standard weights, which is universal. That we have 1 kg weight. It is mentioned over there. It is 1 kg weight, and throughout the word, it is taken the standard that it is 1 kg. Right. So what we do, on this side we put here 1 kg weight, that is the standard weight. On the other side I have 1 kg fruit. Then both this plate will be a straight line, right? It will be in the center only. If my weight of fruit is more, then it will bend like this. It is the unbalanced part. Got it now?
Yes, got it.
Now, when I talk about the balancing of a chemical equation, it means my all the atoms of every element should be equal both the side. It should be equal both the side. Now, what to do? You can see there are 1 nitrogen on the reactant side and there are 2 nitrogen on the product side. So what I do, I put here 2 here, right? 2 here, 2. It means my nitrogen are balanced both the side. Is that clear?
Yes, sir.
And now I have 6 hydrogen on the reactant side, but I have 2 hydrogen on the product side. So what I will do, I'll make it multiply with a 3. Then you can see that I have 6 hydrogen both the side. But my oxygens are not balanced. My oxygens are not balanced. Oxygen on the reactant side is equal to 2 and the product side I have a 3. So if I put here 3, it will become equal to 6. So 3 by 2 is equal to 3. This is balanced, but we don't represent it like this. We make it whole number. Multiply by the whole equation with a 2. You will get here 4 ammonia, 3 oxygen, 2 nitrogen, and 6 water. You can see the complete equation is now balanced. Yes or no?
Yes, sir.
You can see 4 nitrogen on both the side, 12 hydrogen both the side, 6 oxygen both the side. This equation is a balanced chemical equation. And then the physical state gas, oxygen is the gas, nitrogen is the gas, but water is liquid. Mention the physical state at the end.
Okay, sir.
That is how we will be balancing the equation. Understood? Yes or no?
Yes, I understood.
Now I'm giving you one more question. One more unbalanced equation. You need to balance it. Note it down. This equation I have given you. Now you balance it.
So can we give the answer?
Yes, please. I'm waiting for response.
So it will be, I think, 3BaCl2 plus Al2SO4 gives 2AlCl3 plus 3BaSO4.
Everybody
Yes, sir.
agree
I
with
got.
this?
Yes, sir.
Okay, I'm stopping sharing for a minute. Yes, Vedant. Getting this?
Yes, sir. One second, almost done.
It was not correct.
Sir, I'm still doing it.
Okay. So one thing we did last time was a balancing. Other thing we discussed about different types of the reactions. Can anyone tell me what were the different types of reaction we discussed? Smriti Iyer, can you tell me?
So we discussed about displacement reaction,
Hmm.
then decomposition reaction,
Hmm.
and so then in decomposition we learned about thermal decomposition,
Hmm.
photolytic decomposition,
Hmm. Yeah. Good. Thermal
and
decomposition.
displacement reaction we learned about single displacement reaction,
Hmm.
and also in decomposition we also learned about electrolytic decomposition
Very good.
reaction.
Very good. We discussed it. Can you give me examples, Vedant? Vedant, turn on a video.
Sir, give me 1 second.
Okay. Mavish, can you give me an example of a thermal decomposition?
No, sir, I didn't revise.
Read revised. That is not good. Right? Not good.
Sir, may I?
Yes, Prem, please.
Sir, calcium carbonate on heating,
Mhm.
it gives off calcium oxide and carbon dioxide.
Good. Good. Sheikh, can you give me an example of photochemical decomposition reaction?
Uh, 1 minute.
Not revised. Vedant?
Sir, yes, sir, I forgot.
Vedant?
Yes, sir, yes.
Photochemical decomposition, have you done?
Yes, sir.
Then tell me an example.
I'll silver chloride,
Very
when
good.
it is kept in sunlight, it
Hmm.
decomposes to form silver and chlorine.
Good. Very good.
So, sir, now, sir, what was the answer for that one which you gave?
Which question?
The one which you told me to balance it? The barium chlorine
Okay.
chloride, sorry.
We have
So I got the answer as 3BaCl2 plus Al2 gives, and then SO4 outside 3 is there, and then the thrice, and it will give us 2AlCl3 plus 3BaSO4.
I'm showing the answer. Can you see it?
Yes. Yes, sir. I got the same answer.
Good. I'm stopping sharing once again. Last time I discussed about the displacement reaction. And in that respect, I discussed about the electrochemical series, or we can say reactivity series. Yes or no? Who remembers the reactivity series?
Yes, sir.
So we discussed that more reactive species displaces the less reactive species from its solution, right?
Yes, sir.
We discussed that. Okay. Remember this? Yes or no, Vedant?
Yes, sir. Yes.
Have you written that reactivity series? Is reactivity series in front of you? I discussed last time.
No, sir.
Sir, I wrote.
Yes,
Yes,
Smriti.
sir.
Smriti, MK.
Yes, sir.
Okay. I'll be writing the activity series once again, and then we'll go for the some question practice based upon it. Right. Potassium, sodium, barium, calcium, magnesium, aluminium, zinc.
So you're going highest to lowest or lowest to highest?
Upper one is the most reactive.
Okay.
As I'm going down, the reactivity goes on decreasing. Nickel, tin,
Sir, what is Ni?
nickel, hydrogen, copper, mercury. Always more reactive will displace the less reactive from its solution.
So what is the last one?
Hg, H stands for mercury. And below that we have a gold, Au, last the platinum. This is the least reactive. Last time I discussed this.
Yes, sir.
Now, I have an iron reacting with a copper sulfate. You can see the copper is here and iron is here. It means iron is more reactive than copper, so it will be able to displace the copper from its solution. Copper is more reactive than copper. Oh, sorry, iron is more reactive than copper.
So
Yes, please.
I think you've missed writing silver in the series.
Silver is also there. Yeah. Above gold, it is silver here. Understood? So with this, what will happen? The
Sir,
blue.
could you scroll down just a bit?
Okay.
So 1 second. Yeah, okay, sir.
So the blue color of the copper sulfate will fade away, and the green color of the copper ferrous sulfate will appear. Right? What we have, this is by test tube, and here I have a blue color copper sulfate solution. I dipped an iron nail inside it, and after some time I found that it has turned to green because iron has displaced copper from its solution. I hope it's clear.
Yes, sir.
Right. Then from that electrochemical series, from the reactivity series, can you tell me out of lead and copper, which is more reactive? Check from the reactivity series and tell me.
Sir,
Lead
lead.
is more reactive than copper.
Okay. Now suppose I have a lead chloride here and reacting the copper here. Will the reaction take place? Will I get this one?
No, sir.
No, this action not possible. Reason: copper is less reactive than the lead and cannot displace the more reactive element. But if I have a lead and a copper chloride, will the reaction take place?
Yes, sir.
Sir.
This type of displacement is called the single displacement reaction. This type of reaction is called the single displacement reaction. Single element, more reactive element, is displacing the less reactive element. Understood?
Yes, sir.
Now I am discussing double displacement reaction. Last time have we done this topic, double displacement reaction?
Yes, sir.
Right.
Yes, sir.
Who will give me one example? At least one example. I'm stopping sharing for some time. Yes,
Sir, can I?
Vedant, you tell me.
So I have to tell you. Okay. AgNO3 gives plus NaCl gives us AgCl plus NaNO.
Yeah. Okay, will it be okay, everyone? AgNO3 plus NaCl. They exchange their opposite ions. Yes, Mahesh. Smriti here.
Yes, sir.
Is the equation correct? What Vedant has said?
Yes, sir. It's correct.
Okay. Now, I am now going to start today's topic: oxidation reduction reaction. Oxidation reduction reaction. So before I go into the reaction part, first of all, I need to understand what do you mean by the word oxidation and what is the meaning of the reduction. Right? Can anyone tell me what is the meaning of the word oxidation?
So the reaction in which the oxygen is present, I mean, it's reacted.
I am now sharing and write and explain what is the meaning of the word oxidation right now. Oxidation means addition of oxygen or removal of hydrogen. If this takes place, it is called as a oxidation. Let us take an example here. Sodium plus oxygen, it gives Na2O. So you can see that sodium has been added with oxygen, or sodium has reacted with oxygen, and oxide is formed. So we say sodium is oxidized. Now let us balance this equation. This is the balanced equation. So this is the meaning of the word oxidation. Understood? Removal of hydrogen is also oxidation. Can you see that? From the magnesium hydride, hydrogen is removed. And this is called as a oxidation, either addition of oxygen or removal of hydrogen.
Sir, but the equation is unbalanced, right?
Repeat, please. I'm not getting you.
But the equation is unbalanced, right?
Your voice is cracking. Could you please repeat?
So the equation is unbalanced, right? So after writing this, you should balance, right?
No, we need to balance it. Of course, we need to balance it. So now you can balance it. It is 2. So 2.
2 mgH2 plus O2
Yeah.
forms 2 mg plus 2 H2.
Yeah. It is to be balanced. Yes, of course. But I was focusing upon the concept. What is meant by the word oxidation? Oxidation means addition of oxygen or removal of hydrogen. I can say the magnesium hydride has been oxidized. Understood the concept?
So,
Yes, please.
so it is addition of oxygen and removal of hydrogen, or is it like any one of them will happen?
Any one of the two.
Oh,
Now we talk about reduction.
Sir, I have a doubt.
Yes, please ask me about.
Sir, for oxidation, will both will take place, addition of oxygen and removal of hydrogen at the same time?
No. It can take place. Yes, I'm going to give an example. No, actually not. The one thing that you're telling me is not possible. Not both the ways altogether. Let's take up an example here. I'm giving you one example here. Copper oxide plus hydrogen. It's a copper plus H2. No, not leave it. I said either addition of oxygen or removal of hydrogen, not both at a time.
Okay, sir.
Now reduction is just opposite. It is addition of hydrogen or removal of oxygen is called reduction. Understood? Now I say let it be copper oxide plus hydrogen. I'm getting copper plus water. You can see from the copper oxide the oxygen has been removed. So we say the copper oxide is reduced. At the same time, you can see we are adding oxygen to the hydrogen. It means hydrogen is oxidized. Hydrogen is oxidized. The same reaction, oxidation and reduction is going on. Copper oxide is reduced and hydrogen is oxidized. Getting me?
Yes, sir.
Now, take up another example. Yes, please.
So it's reduced and it's
Yeah, copper
Yes,
oxide is reduced and hydrogen is oxidized.
okay.
Now taking up another example here. Fe2O3, aluminum, Fe, Al2O3. Right. You can see the iron oxide has been reduced. It's a reduction. I can say here I have removal of oxygen, and aluminum has been oxidized because addition of oxygen. Am I clear?
Yes, sir.
Yes, Vedant, are you getting this?
Yes, sir.
Note it down, everyone. Getting everyone?
Yes, sir.
Now, I'm giving another example here. H2S plus Cl, HCl plus sulfur. So you can see here removal of hydrogen. What do you call removal of hydrogen? Oxidation. And here hydrogen is added. It's a reduction. Understood?
Yes, sir.
Noted.
Also, can you move your cursor?
Note it down.
Yes, sir.
Now, I will now go back to this equation here. In this, the hydrogen is responsible for removal of oxygen from the copper oxide. So I can say this H2 is a reducing agent. Here hydrogen is the substance which is taking out, which is snatching, which is removing oxygen from copper oxide. So I say hydrogen is a reducing agent. Is that clear? And copper oxide is giving oxygen for the oxidation. It means the copper oxide is an oxidizing agent. I hope it's very clear.
Yes, sir.
Yes, sir.
And in this equation, can you tell me what is aluminum here? Oxidizing agent or a reducing agent?
Reducing agent.
Vedant will tell me what is this Al.
Also, can you, sir, please ask a question.
Yeah, Vedant. What is this? Oxidizing agent or a reducing agent? Fe2O3.
Sir, oxidizing agent. Sir, could you go back to that copper oxide when I want to note it down?
So can you explain how H2 is a reducing agent?
It is taking out the oxygen.
Or
Hydrogen is responsible for the reduction of copper oxide. It is taking out, it is snatching the oxygen from the copper oxide and reducing it. And
okay, sir.
copper oxide is oxidizing agent because it is giving oxygen to the H2 for oxidation.
And done, sir.
Okay, sir.
Similarly here, Al aluminum is snatching oxygen from the Fe2O3. And Fe2O3 is adding oxygen to the aluminum as the oxidizing agent. Am I clear?
Yes, sir.
In this case, tell me which is the reducing agent. Vedant will tell me.
So reducing agent is H2.
Which is H2? I don't have H2 anywhere.
Sorry, H2S.
Brain. What is oxidizing agent here? Brain. Are you
So
there?
sulfur.
Sulfur. It is only the reactant side. Chlorine. Chlorine is taking out the hydrogen from the H2S. Oxidizing agent or reducing agent is to be determined from the reactant side only. One of the two is oxidizing agent, other is the reducing agent. Right?
Okay.
Now, I am giving you now one more example.
So is that MnO2?
Yeah.
Okay.
In this case, which is the oxidizing agent? Wait a minute, please. Smriti Iyer and Joe Daniel. Joe Daniel. You people will tell us. Wait. Okay, Smriti.
Yes, sir.
Which is the reducing agent here?
Sir, it's MnO2.
How?
Yeah, because oxygen is getting reduced in the product side.
So this is undergoing reduction, right?
Yes.
But my question is not which is undergoing reduction. My question is which is reducing agent, which makes the MnO2 to lose oxygen.
Mn.
No, HCl. HCl is a reducing agent. It is causing.
So I have a question.
Yes, please.
So most of the elements which have H in it, is it a reduction agent or it's just some coincidence?
Not necessary. Not necessary. I will give you many examples now. If I talk about this question,
Sir, it's actually a bit confusing. The
no. It is not. Wait, remove this word. Don't speak this word. Confusing. There is no confusion in chemistry. Only you need focus in my class. This is aluminum. Can you see? It is responsible
Yes.
for
Yes.
it is responsible for the removal of the oxygen, and it's a reducing agent. So your statement was hydrogen containing compound is a reducing agent. That is wrong. You said
Okay.
right, not necessary, which takes the oxygen. That can be hydrogen.
So if I say that in a reaction in which hydrogen is there, in that
Maybe
Yes.
it still it may be. I will not.
so it's not 100%.
No. I need to see the equation.
Okay.
I need to see the equation. So this HCl is responsible for the removal of the oxygen from the MnO2, and that is why it is a reducing agent. Is that clear?
Yes.
Everyone?
Yes.
Don't use the word confusing. There's nothing, no confusion in chemistry. It's very simple. Only thing is you write it, understand it, practice it. And next time when you come in my class, don't come blank. Like today you have come blank. Last time whatever I taught you, you have not revised. It will be not only confusing, it will be most boring also if you come like this. If you come like this, that you are just attending the classroom like a movie, then it will be confusing. You got it now, everyone? Last time, whatever I taught you, have you practiced? Maybe she has adapted, she has admitted that she has not revised. This type of will not give you anything. Whatever I teach you, revise it. Then you come in the class, then there is no confusion. Right? Right, Vedant?
Yes, sir.
Yeah. So, who revised it? Who admitted? Who revised? Sheikh?
Sir, I only did that balancing equation.
Yes, sir. Even I
I also did one.
Okay. Don't read it only. Don't read it. Write it. Right? When you write it, there's a permanent, it goes in permanent memory. Reading will not help you a lot, right? Do it like that. It'll be much. Yes, MK, you are not speaking. What is the full name? I don't know what is MK.
That's Manasi Kamach.
Mansi.
Manasi Kamach.
Okay. I'll be calling it MK. Otherwise, change your name, please. Change your name in the right, in that Zoom.
This will change it.
Okay. It is not confusing. Only lack of practice. Then it will be boring, confusing, whatever words you can speak of. Okay, come to this now. Is it not clear that HCl is the reducing agent here? Yes or no?
Yes, sir.
Anyone having any doubt regarding this? How is HCl as a reducing agent?
Sir, because it is taking oxygen from the Mn.
Yeah. And now, if you see this, MnO2 is giving the oxygen to the hydrogen and that's converted into water. It means to the hydrogen, oxygen is added. So what is happening here with the HCl? It is oxidation or reduction? What is happening with the HCl? Addition of oxygen. Oxidation. Yeah. What's the confusion? Nothing. Very simple. And now my question is, which is the oxidizing agent? Which species among these is the oxidizing agent?
MnO2.
Yes. Now, do you have any doubt about it?
No, sir.
Very simple. No confusion.
No confusion, sir.
But don't use such type of words in my class. Come to learn and learn. That's it. No confusion, no doubt, nothing. Simple. Get 100% marks. Okay, now come to next topic now. Here I have an H2S and here I have an SO2. It gives sulfur and H2O. So identify which substance is undergoing oxidation, which substance is undergoing reduction, which is the reducing agent and which is the oxidizing agent. Answer these questions now. Start with Vedant. Which substance undergoes oxidation?
Sir, oxidation. 1 second, sir. Sir, SO2.
You mean we are adding oxygen to the sulfur dioxide?
No, sorry. From that we'll remove it's a reduction.
No,
H2S.
Wait. Vedant, I want only one word. I don't want anything, no statement. Which substance undergoes oxidation? That's it. I don't want any justification.
Sir, 2H2S.
H2S. Which substance undergoes reduction? Joe Daniel.
So SO2.
SO2. MK. Which is a reducing agent here?
Yes, the reducing agent is
Can I answer?
Yeah,
H2S.
H2S. H2S is removing the oxygen from the sulfur dioxide. Right? Okay, oxidizing agent.
SO2.
SO2. Everybody got it?
Yes, sir.
Any doubt till now?
No, sir.
No doubt, sir.
Vedant?
Yes, sir.
Any doubt?
No, sir.
Any confusion?
No, sir.
Very simple, right? Smriti Iyer, where
So
are you?
just a bit of mix up between oxidation and reduction.
Okay,
I can't tell which one is taking
okay,
place.
okay. Smriti Iyer, your camera should be on your face. It's just on your head only.
So can you see now?
Yes. Very big. Okay. Now everybody is involved with the subject. Are you writing all these things? Sheikh, are you also writing?
Yes, sir.
Vedant,
Yes, sir.
can you show me notebook like this?
One
Yeah,
second,
show me
let
like
turn up the
this. Show me like
filter.
this.
Yeah, let me turn up the effect. One second.
Okay. 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 Perfect. Understand, everyone. When I say oxidation, it means addition of oxygen or removal of hydrogen. If any substance, to any substance oxygen is added or from which hydrogen is removed, it's oxidation. Reduction is just opposite. Addition of hydrogen or removal of oxygen. Is that clear?
Yes, sir.
Very simple. I'll give you some examples here. Now, what is happening here? What is happening with the magnesium? Oxidation or reduction?
It's combining, it is oxidation.
Oxidation.
Oxidation. Right. We have discussed till now combination reaction. We are done last time.
Yes, sir.
Decomposition reaction. We had done the displacement reaction. We had done the double displacement reaction.
Single displacement reaction.
Single displacement reaction. And today we have done oxidation and reduction reaction. Now I will be writing equation and you have to identify which type of reaction it is.
Okay, sir.
Starting with Joe Daniel. You have to tell me which type of reaction it is. Quick. It's not a difficult topic. Yes, Joe Daniel?
So decomposition reaction.
Decomposition. Everybody agree with this? Everybody agree with this, Vedanta?
Yes, sir.
Okay.
Yes, sir.
Smriti Iyer, now you tell me what type of reaction it is.
Yes, sir.
Taking too much time?
Sir, is it displacement reaction?
What type of displacement reaction? Single or double?
Single displacement reaction.
Good. Single displacement reaction. Now Vedant will tell me what type of reaction it is.
Sir, decomposition reaction.
Decomposition. MK,
Yes, sir.
what type of reaction it is?
So it is a mixture.
Mixture. I have
Sir,
given.
may-
Yes, yes.
So combination reaction.
It's a combination reaction. Two substances are combining. I have not taught you anything as a mixture reaction. Okay. Understood?
Yes, sir.
Right.
Yes, sir.
Now next topic write down rancidity. Rancidity. I have stopped sharing for some time. Maybe shake, turn on a video.
Yes, sir. 1 minute.
Frame and MK, next time please your mic and the camera should be on. Right?
Yes, sir.
I don't want anybody at the backbenchers. First should be in the front line. Right?
Yes, sir.
And next time when they're coming in the class, come prepared. Don't come unprepared. Huh? Revise everything, write it, and it must be on tips. Not like today. Whatever the class we did last time, we are not properly revised or not revised at all. Yes, Vedant, where are you watching?
No, sir. Nothing.
Okay. I'm talking about the word rancidity. What is the meaning of the word rancidity? Understand? Do you take some type of chips, packaged food as a chips, like Lay's or something?
Yes, sir.
Yeah. And you might have seen that the packet is filled with some type of the gas inside, along with the chips.
Yes, sir.
Yes, sir.
Which
I
gas?
think it's nitrogen
Nitrogen. Yeah. Why nitrogen is filled?
to keep the chips fresh.
To keep the chips fresh. Okay.
So that the food doesn't get spoiled.
The food does not get spoiled. Okay. Technically speaking,
So give me 1 second, I'll be back, sir.
yes.
So just give me 1 second. I'll turn off my video for 1 minute.
So technically, what happens? I'm talking in terms of the chemistry. You are saying prevention from spoilage, and Vedant was telling me that keep it fresh. It's a very common man's language. Yes, sir.
Yes, sir.
It is not a scientific language at all. What is
Exactly.
happening? What is happening at a scientific level? We will discuss that. Actually, that food, maybe that chips or maybe some biscuits, maybe some type of packaged food in there. On that packet, that company has mentioned an expiry date. What is the meaning of the word expiry? Expiry date.
We should like use it before that day, like the given day.
Before that day, we should use it, otherwise it will get spoiled.
Okay. They mention like this manufacturing date is this, and then they mention at the bottom to be consumed before 6 months. Yes,
Yes, sir.
or right, or if you see some medicines, proper medicine, proper date is mentioned. After that, that medicine will become poison. But our food material, maybe chips or biscuits or any such packed food, it becomes sour in taste. Have you ever experienced this? You have taken a biscuit packet and when you opened it, you felt some type of smell in it, and when you eat it, it is having some bad taste. Have you ever experienced this?
No, sir.
No.
No.
Chips will finish within 1 week only. It won't last 6 months.
Okay. No, sometimes it comes in the market and it is kept to the shopkeeper for some days, right? And expiry date is also closed, and then you buy it. Right? Sometimes it happens like that. Sometimes the company makes some type of mistake on it. The old food is given with a fresh date, right? So many times it is observed that you open a chips packet and you taste it, it is sour in taste. It is not looking fresh. The reason behind this, I'm not talking about the technical part of it. All these foods, maybe these chips or biscuits or something else, some type of fat is added to it, oil or fat. They are cooked in oil or fat. If that oil or fat undergo oxidation with the presence of the oxygen, that will turn to some acid and that will be sour in taste. So to prevent the oxygen to come in contact with the food material, they fill it with nitrogen. That nitrogen will not come in contact with the food. Oxygen will not come in contact with the food. And in case of the biscuits, they add some preservatives like PHA, butylated hydroxytoluene, or BHA, butylated hydroxyanisole. These are the preservatives they add so that the oxidation of the food fat does not take place. So what is acid rancidity? Write down the definition of rancidity. I'm sharing my screen with you. Oxidation of oils or fats in a food resulting into a bad smell and bad taste is called rancidity. It's called rancidity. Noted down, everyone.
Yes, sir.
Now, how to prevent rancidity? Write on prevention from rancidity. Number one, by the addition of antioxidants like BHA or BHT. BHA is butylated hydroxyanisole and BHT stands for butylated hydroxytoluene. These are the antioxidants which are mixed with the food material to keep
So butylated hydroxide.
hydroxyanisole
Yes, sir. Okay.
or butylated hydroxytoluene.
So do we need to learn that name?
Yeah. These are the name of the chemicals which are added to the food material to prevent from the rancidity.
Okay.
Second, by the note it down. Butylated hydroxytoluene, TOLUENE. Done.
Yes, sir.
Second method is vacuum packing. Packing in the vacuum. Air will not come in contact with the food. Or replacing air by nitrogen. And next method, refrigeration. Of the food stuff. These are the four different methods by which we can prevent rancidity. Understood? Noted on everyone?
Yes, sir.
Do you find any difficulty in understanding this topic? Very clear? Okay. Then just give me a minute. I'll be opening one. I'm opening one file where we will be discussing some questions today. Just a second, please. Okay. Vedant, turn on video.
Yes, sir.
Compulsory. All my students should be in the front line. No backbencher. Right?
Yes, sir.
Now I'm sharing my screen with you. Can you see exercise?
Yes, sir.
Okay then. Let us start with these questions. Which of the following reaction involve combination reaction? Start with it. Check it. It may be more
So
than one correct answer. It may be more than one
the
correct answer.
first one,
First one, yeah.
and
Can I say all of these are combination reaction?
yes, sir.
All of
Yes,
these are
sir. All
combination.
of them are.
Yes. Okay. Now I'm giving you these three questions. Wait. Second, third, fourth, 10, 11, 12, 13. Right? These 7 questions. You get their answers. You read it and come to the conclusion. I'll be coming back just in 1 minute. Right? You read it and come to the conclusion of some answers. I'll be back in a minute. Okay, have you done, everyone?
Sir, doing.
Done, everyone? Vedanta? Ready?
Started doing the 10th one.
Okay. I have stopped sharing by the time. Yes, Smriti, over here, have you done?
Sir, I have two more to that. I was doing the 10th one.
Okay, so I'm sharing my screen. Let us discuss. Second question. What's your answer?
Sir, double
Sir,
displacement
double
reaction.
decomposition reaction.
Double
Decomposition.
decomposition reaction.
That's
Double
true.
decomposition reaction.
Good. Next.
No reaction takes place.
No reaction takes place.
No reaction.
No reaction. Why it is not taking place?
Because
Because sir,
copper is less
the
reactive than
copper
iron.
copper reactive than iron.
Yes. Anyone having any doubt?
No, sir.
Next, number 4.
A
Sir, the
gas
gas
revolves
evolves with
which burned with a pop
with a
pop sound.
pop sound.
Okay. Basically, what is happening? Zinc plus HCl, right?
Yes, sir.
ZnCl2 plus
Then
H2,
CO2 plus
right?
H2.
And this hydrogen get burned. So, B option. Right? Anyone clear?
Yes.
Okay, the 10th question.
It's a
10th
reducing
question,
agent.
sir, it's a
Reducing.
B.
Reducing agent, right? Next. This is a redox reaction. You can see
Sir,
the
can you explain the 11th one?
11th I'm explaining. How do you, what is the meaning of redox reaction? See, copper oxide, hydrogen to give copper and H2. What is happening with the copper oxide? Oxidation or reduction?
Sir, it is losing oxygen.
What is happening with it? Oxidation or reduction?
Reduction.
Reduction. And what is happening with the hydrogen?
Sir, it is gaining oxygen, so oxidation.
And the reaction in which one substance is oxidized and other substance is reduced, that reaction is called as a redox reaction.
So once again, I'll note it down.
RED for reduction, OX for oxidation. It means the substance in which one substance is oxidized and other substance is reduced, the reaction is called as a redox reaction. Am I clear?
Yes, sir.
Twelfth question.
Sir, reducing agent.
Yes, it is. 13th question.
Sir, in 13th D.
One substance is oxidized while the other is reduced.
Good. Everybody clear?
Yes, sir.
Okay, then come to 5th, 6th, and 7th. I'm giving you 2-3 minutes. Work upon 5, 6, 7. Then 14, 15, 16, 17. All of this. I'll discuss all together. Basic 7 is done.
Sir, is fifth one C? A colorless gas liberated in test tube A.
Let's check. A dilute solution of sodium carbonate. Sodium carbonate is NaCl. Was added to 2 test tubes. One containing HCl. Test tube A. Other containing sodium hydroxide. The correct observation. Here I will get NaCl plus H2O plus CO2. In this case, no reaction will take place. And this CO2 gas is colorless gas. So colorless gas is liberated in the test tube A, means option C correct answer.
So can you explain again? I still didn't understand.
Reaction that last time we discussed the reactions. If you remember the reaction, then we can give the answer. Sodium carbonate react with HCl, it form NaCl plus H2 plus CO2. CO2 is the colorless gas. But these
Yes.
two do not react. So it means answer C is the correct answer. Because when you come to the question practice, your theory should be up to date on tips.
Okay, sir.
Right? Our classrooms are not for fun, huh? Our classrooms are for learning. When you're coming for our class next time, your theory must be on tips so that we can practice more questions. Right, everyone? I'm not talking to any one particular person. I'm talking to all of you.
Yes, sir.
Was it clear? That question was clear?
Yes, sir.
Sharing your screen once again. A balanced chemical equation is in accordance with I'm telling the answer here. Law of conservation of mass.
Law of conservation of mass.
Of conservation of mass.
Yeah, the total mass.
So on the screen share, I can see the Google meeting.
Can everyone see?
So we
You
are
can see Google Meet.
but not presentation tab.
But I'm sharing my. Wait. Wait. Now I can see.
Yes, sir.
Yes, sir. Law of conservation of mass. Yes.
That is total mass of reactant is equal to total mass of the product.
So can I answer the seventh one?
Yeah, answer please.
So the C, 4 and 2.
Everybody got this?
Yes, sir.
Yes, sir.
Vedant,
Yes, sir.
have you done?
Yes, sir. I only gave the answer.
Okay. Okay, question number 14 now.
Sir, 8 and 9 are also there, right?
Pardon?
Sir, question number 8 and 9.
8 and 9. Hmm.
Eighth is a single displacement reaction.
Okay, good.
Sir, ninth one is a double displacement reaction.
Yes. Now coming to the 14th question.
Sir, I can answer can I answer the 14th one?
Sure.
Sir, option B, 2.
Good. Next.
So 15th one, it's I think an acid.
Yes. It's a base. Sodium hydroxide is a base. Nitric acid is an acid. It's an acid-base reaction. Next.
It's a displacement reaction.
More appropriately, single displacement reaction.
The 17th one will be C.
Then what?
17th one is A.
Yes.
Gray. It becomes gray.
Yes. It becomes gray.
Oh, okay.
Next.
Black and white photography uses decomposition of silver bromide.
Good. Next. When copper powder is heated, it becomes Q2. What is this? Red copper oxide. Remember. Next.
Oxidation reaction.
Good. It's a phosphorus plus oxygen to give A2O5. Rest we can go balancing. Next.
Rusting of iron is an example of oxidation reaction.
Yes. Iron plus oxygen, it forms an Fe2O3. The oxidation reaction. Next.
Sir, gold, copper, and silver.
Copper, gold, copper.
Gold does not corrode when
Yes.
exposed.
Silver undergoes oxidation, it forms Ag2S.
So the copper also, yeah, copper will go, yeah, yeah.
Yeah, it forms Ca2S. Next.
It's a decomposition reaction.
Good. It's a decomposition reaction.
So that you marked double displacement as the answer.
Mhm.
Sir, I think it's the third one. 2FeCl3 plus H2S gives 2FeCl2 plus 2HCl plus S.
H2S is getting oxidized. It is giving hydrogen. Yeah, okay. Yeah, right. 25th.
Redox reaction.
Copper redox.
Say option A.
A option. Understood, everyone?
So 27th is B reduction.
Yes. Gain of electron is called reduction. Gain of electron is called reduction. Yeah. Which is not correct.
So can you scroll down a bit to see the other options?
Hmm. Which is not
So I think
correct.
so. All of them.
A chemical reaction tells about the substance involved in the reaction. The statement is correct. What is combining? What is being product? A chemical reaction informs us about a symbol and a formula. Yes. Chemical reaction tells us about the atom molecule reacting involved. Yes. Energy changes. Yes. So question is which is not correct. Energy changes is not involved. Energy
So,
changes
but in the question it is written more than one option we can choose.
we can choose, but other three are correct. We can choose. It does not mean we can. Wait. Only we have to choose the correct answers. Okay, which is following a decomposition reaction.
The first one is a decomposition reaction.
Second,
Yeah, that's also, and the third one is also
yeah,
decomposing.
yes.
It's a double displacement reaction.
Good. Vedant will tell.
Yes, sir. One thing. Mm, sir, PBO is wait. C is acting as a reducing agent. Sorry, C is acting as an oxidizing agent. Sorry.
No, it is taking out oxygen. It's a reducing agent. And PBO is getting reduced because removal of the oxygen is going on.
Oh, okay.
Right? So A and C both are
Yeah.
correct.
Okay, sir.
Getting me? No,
Yes,
next.
sir.
Next.
It gives lead oxide, oxygen,
Yes.
and also it gives, I think, nitrogen dioxide also.
No.
So, but then we told that it gives lead oxide and it gives oxygen, but we are telling it's nitrate also, but like it can, like it won't give nitrogen dioxide as well.
Hmm. Yeah. Okay. Next.
Carbon dioxide and quicklime.
Everyone getting this? CaCO3 gives CaO plus CO2. Yes or no?
It gives ferric oxide, oxygen, and sulfur dioxide. Rancidity can be prevented by adding antioxidants and packing oily food and nitrogen gas.
Decomposition.
Both A and B.
Endothermic process.
Boiling of water is an endothermic process.
Dissolving salt in water and
Evaporation
evaporation.
of water.
Tenth question.
Say option C.
Displacement reaction. Yes.
Option C and D.
D is a
It's a double displacement, right, sir?
yes. So still we can put it under displacement.
Okay. So then it is A and C in the 11th one.
Addition of oxygen and release of the hydrogen. Yeah. Okay, come to this question.
This is an oxidation reaction.
Yes, it is. It is metal iron is oxidized to Fe3O4. That is also
Sir,
correct.
B and D.
B is also correct.
It gives potassium chloride and oxygen.
Potassium chloride and oxygen. Yeah.
Sir, in the 12th one is D correct?
B is correct. Yeah, metal iron is oxidized to Fe3O4. Yes. Fe3O4. This is the Fe3O4. Misprinting here. Make one change there.
So the correct answer is A, B, and D.
No, not D. Fe is not getting reduced. It is getting oxidized.
Oh, yes.
It's a combination reaction, the 14th one.
Yes, it is a combination reaction.
I think it's also an oxidation reaction.
Very good. Ammonia gas is formed by the combination of nitrogen and hydrogen.
So the A and B both are correct.
Nitrogen and hydrogen are reacting. One molecule of nitrogen
Nitrogen combines with 3 molecules of hydrogen and forms 2 molecules of ammonia.
and C part, one volume of nitrogen, 3 volumes of hydrogen. This is also correct.
Yes, that is also correct.
D part is wrong. Right?
Yes, sir.
They are not gases. All these are gases, right?
Yeah.
Next, double decomposition reaction are
The
Sir, B,
K O
C, and D.
B C D are double decomposition.
B, C, D.
Except for A, all.
Yeah.
It's a combination reaction.
Combination reaction. Yes. Okay.
So can we say it's an exothermic reaction as well?
Yes, it's exothermic. Yes. You're right. Yes, I'm waiting for response. Copper will displace only from the less reactive element.
AgNO3.
Yes. When the copper is more reactive as compared to the one, right? So you have to refer to the reactivity series. Okay, which of the following side can be decomposed with difficulty? Everyone, Vedant, take.
Yes, sir. Sir, it will be option C.
Which of the following statement is correct?
Sir, I think D.
Yes.
Sir, it can be A also, right?
Yes, A option right. But those who are at the top, they are not found in, they are always found in the free state, right? Yes, Mavish, Joe Daniel, turn on my video.
It's just 1 minute.
Yes, Smriti, everyone got the answer?
Yes, sir.
Yes. Okay, I'm sharing my screen again. Wait. Can you match here?
So what do we have to do in this when I don't understand?
If it is decomposed, it is giving KCl and oxygen, right? It means
Yes,
A.
sir.
It means A. It means A is only P. Zinc carbonate will give you zinc oxide and carbon dioxide. It means B is R. Okay. This will give you carbon dioxide plus water. It means C will be giving Q and R.
So for the B1, it will be S and R also, right? Because it gives ZNO plus CO2.
Yes. And this will give you carbon dioxide and water. Means Q and R.
It's the first one.
Yes. Got it now? You should know only the products of the reactions. Then only you can do it. Yes or no?
Yes, sir.
I stopped sharing. I stopped sharing for some time. Okay. Today you have learned something. Yes or no?
Yes, sir.
Yes.
Yes,
Next-
So we can do the integer type question as well, right?
Yes, of course. I am sending you this file. You do the remaining questions, right? And next time you ask me your doubts. I'm sending you this file. Next time you ask me your doubts. And come prepared. Prepare the complete
Sure,
chapter.
sir.
It is almost completely done. Right? Chapter is complete. Now question practice. You do it and ask me your doubts also. Okay?
Okay, sir.
Okay, now I'm
Yes.
ending session now. See you next
Thank you,
week
sir.
at the same time. Goodbye for now. Bye.
Thank you, sir.
Thank you, sir. Bye.